All right, this recording, in conjunction with what we've done before, continues what we've been talking about. We've so far talked about chords that intersect in a circle. We find that they divide their parts so that the products are constant. And then chords that intersect in a circle, if you want to find the angle between the chords, you average the intercepted arcs. And that's how you find the angles. Now we're going to deal with secants, and secants that intersect outside a circle. So let's go ahead and draw a circle. Draw a circle. Here we go. Oh, grab the move tool here. Sometimes you want the move tool and don't realize you don't have it. Okay. And I'm going to draw a line segment that intersects or meets, two line segments that intersect or meet outside the circle. And you can consider these to be lines as well if we went forever in both directions. And I'm going to label the points at which they intersect the circle F and G. And let's talk about length. So we're going to measure distance. So distance between F and C. Actually, I want to measure the distance between F and D, and the distance between C and D, the distance between G and D, and the distance between E and D. And just as before, we're going to look for some relationship between these measurements. Now, there are 4 different measurements. Well, they're kind of equal here because of precision here, round off error here. So, but you can see there are 4 different measurements here, 8.1, 7.6, 17.7, and 19, and we're looking for some sort of relationship between them. Well, let me switch to algebra here, and let's input again. Don't need the input here. And I'm going to take the outside part, df, and I'm going to multiply it by the whole, dc. The outside part times the whole, dc, and that gives me 143.3. And that's assigned the letter A here, little a. Now I'm going to take the outside times the whole on the other one as well. It's a dg times de. Or, nope, not ge, de. There we go. And we get a product of 143.3 again. You'll notice both products are the same. Does it matter where I go? No. No. So it doesn't matter where I go. 66.9, 66.9, 23.6, 23.6. No matter where I draw these, the product, 198.9, 198.9, is the same. So let's talk about how that works in a problem. Okay. So let's go get rid of that, and here we go. So here's how you might see this in a problem. You're given a circle, and you're given 2 secants. Secants are lines that intersect a circle twice. Okay, and they're going to meet outside the circle. Outside the circle. Okay, and let's say we know let's label these points. A, try that again. A, B, C, D, E, and F. And F. It's already C. Okay. All right. And here's what the rule that we just discovered says about the lengths. It says the outside part times the whole thing equals the outside part times the whole thing, right? So it says, in other words, that BC times BA equals CE times CD. The outside part times the whole thing is consistent, it's constant. All right, so let's supply some numbers. Let's say this is 12, and this is 8, And this is 9, and this is x. Okay, so the outside part, 8, times the whole thing, 8 plus 12, equals the outside part, x, times the whole thing, x plus 9. Okay, there we go. So this is the kind of equation you're going to end up getting. So 8 plus 12 is 20, and 20 times 8 is 160. X times x is x squared, 9x. We get a quadratic, and that's not unusual in these problems. Okay, so we're going to now subtract 160. X squared plus 9x minus 160 equals 0. And I'm just going to use the quadratic formula. You can try to come up with factors of 160 whose difference is 9. You may or may not find one. I'm going to go to Desmos here, and I'm going to use Desmos. Here's how I like to do the quadratic formula. I just assign variables. A is 1. That's the coefficient on the x squared. B is 9. C is negative 160. Negative 160. So let me remind you where I got those numbers. Where do I get 1, 9, and 160? I get it from 1 on the x squared, 9 on the x, negative 160 on the constant, on the no x. And now once I've got that, I just type the quadratic formula, which is negative b plus or minus square root b squared minus b squared squared minus 4ac all over 2a. And I get 8.9 for the plus 1. And I get, when if I change it to a minus, I get negative 17.9. And only the positive one makes sense. So x is approximately 8.9. Okay, so that's how you'd be expected to use the formula. Outside times the whole equals outside times the whole.